Guys. Okay, hello, hi. Okay, so today we're going to be learning about pressure. So the different units of pressure. We're going to look at kPa, which is going to stand for kilopascals. mmHg is millimeters of mercury. ATM is atmospheres, and MB, not Manitoba, it is millibars. That's kind of a weather, generally speaking. You'd use that one. It's a weather term, not used that often. So this unit is our gas unit. So we're going to talk about pressure a lot here. So we're going to sort of go through. We're going to go through different ways. Sorry. We're going to go through the different ways to convert between the different units of pressure here. So pressure conversions. So we've got 1 atmosphere is equal to 101.325 kPa, is also equal to 760 millimeters of mercury. So these are not new for you. You would have had to memorize these in our first unit when we talked about STP, right? So the only new one here is our millibars, and you'll notice that these two are related by a factor of 10. So if I multiply kilopascals by 10, I get millibars. We are going to use dimensional analysis, our friend, our favorite, to convert between units. Okay, so first question we're going to look at here. So convert 2.00 atmospheres to millimeters of mercury. So again, we're just going to use dimensional analysis. So what are you looking for? Yeah, you're looking for millimeters of mercury, and then equals, you're going to write down what you know. And then you're just going to multiply that by your conversion factor. So remember that diagonal units are always the same. So if you see atmospheres here, you're going to put that on the bottom. And then millimeters of mercury goes on top. And the conversion factor between those, if you look back, it's going to be these ones here. These are the conversion factors between them. So it's going to be in 1 atmosphere, there are 760 millimeters of mercury. And then you're just going to multiply your answer out as you would normally. So it's just going to be 2 multiplied by 760. And you get an answer of 1,520. And your unit then, millimeters of mercury. Now, do you have to worry about significant figures when you're doing conversions like this? No. So you would use whatever you get here. You're going to use the full value for whatever you get. But as we move along further, if you needed to look back and figure out where the significance came from, it would come from this. So that would be the 3 sig figs there. But we'll talk more about that later as we start to problem solve with the different gas laws. Okay, this one, convert 3.5 kilopascals to millibars. So what you're looking for is millibars. What you know is 3.5 kPa, so kilopascals. Now it's just a factor of 10 between them, but we're just going to use dimensional analysis to keep it simple. So we've got kilopascals on the bottom, we've got millibars on the top, and this is going to be 101.325, and here 1,013.25. So just a factor of 10 between them here. So your answer is going to be 35 millibars. Okay, next. Okay, so how do we define pressure? So generally speaking, when we're talking about pressure, we tend to think about the pressure that people are under. So you guys right now will be, with online learning, some of you I know are feeling quite a bit of pressure. If I asked you to use your hands to describe pressure, what would you do it with your hands right now? Yeah, you'd have probably your hands kind of pushing together a little bit. Everyone kind of tends to make the same motions or around your head. But how do we define pressure in terms of a science term? We can define it as the force that exists per unit area. So lots of you probably thought about the word force in there. particularly if you have a physics background. So we can think of it in unit area, or we can think of it in three-dimensional in terms of like a volume or a certain space as well. So the amount of force per unit area, that's how we're going to define pressure. Now I'll give you these two examples here. So we've got a flat shoe and we've got a high-heeled shoe. Now I want you to think back and think about, was there ever a time where you got your foot stepped on by someone wearing a high heel? And if you had, how did that feel? Oh, that feels terrible, right? Horrible, very painful. Have you ever had your foot stepped on by someone wearing a flat shoe? Yes, I'm sure you have. We all have. Is it that painful? Not too bad, right? So why the difference? So the difference is just simply going to be related to the space, right, and the area. So if you look at this shoe here, where the shoe's hitting the ground is a very small area, very small surface area versus this whole area here. So if you think about it, the mass of the person in the flat shoe, that mass is going to be distributed out all through the shoe, whereas in this high heel, that person's entire mass is in those very small areas. Sometimes you can see it in flooring. If you have like a vinyl flooring, or at the school, we'd even be able to see it in the tile flooring at the school. You can see little crescents. Sometimes there's these little divots in floors, and those are literally from high-heeled shoes, and it's from the just pressing in there, as there's actually a very large amount of force pushing down because there's such a small surface area there for those shoes. Of course, conversely, we have these. What are these? Some of you know. Do they make you snowshoe in gym? Sometimes they used to do that. The school used to have snowshoes. So this would be like a First Nations invention then, right? So snowshoes, they're designed to widen or provide more surface area for the mass of somebody. So the point of wearing these is that you are now able to walk on the snow, and ideally, hopefully you won't sink down. You can actually walk much easier on top of the snow. So it just distributes your whole mass over a much larger surface area. So much less pressure when you wear a snowshoe. Okay, so I want you to think. So what exerts the most pressure? So what has the most pressure associated with it? The pressure of salt water, the pressure of the atmosphere, or the pressure of fresh water. So which one is going to exert the most pressure? And I want you to arrange yours from which one has the least amount of pressure to the most amount of pressure here. So I want you to pause the video right now and think about it and try to come up with your answer. So pause. Okay, hopefully you've come up with an answer here. So what exerts the most pressure? So a lot of you will have said the atmosphere. Now, I want you to think about it in terms of what can support your mass. This is a good way to think of it. Can you float on water? Can you float on fresh water? Yes. Can you float on the atmosphere? No. Can you float on salt water? Yes. So which one's going to have the least amount of pressure? It's going to be this one. So P atmosphere is going to be less than, and now which one's next? Is it fresh water or salt water? Some of you have probably swam in the ocean, which is salt water, right? So what's the difference between swimming in the ocean versus swimming in fresh water? If you try to float, it's easier to float in salt water than it is in fresh water. And the reason for that is, hold on here, oops, that's salt. The reason why you can float easier in the salt water, it's got a certain amount of more pressure associated with it because you've got more parts in a certain amount of volume. So if you had, 1 liter of fresh water versus salt water, fresh water is simply H2O. But salt water, we've got our H2O plus our Na plus Cl minus, because the salt is going to dissociate in the water. So you've got both things. So you've basically just got more particles in a certain amount of volume than you do in the fresh water. So that's why our salt water here would exert the most pressure. Whoops. Now, hold on 1 second. Okay, why don't you hold your breath when scuba diving and rising to the surface? So this all has to do with pressure. Some of you maybe have been scuba diving. I have not. It seems like a death trap to me. I will never ever do that. So hopefully you risk takers, you can do that and have fun with it. But everyone who has been in a swimming pool has probably experienced this. If you dive down, if you dive down in the water, generally you can feel the pressure building. I don't like it. I don't like the feeling of it. I don't like it pushing on my head. And it pushes in on your ears too. I know some people have issues with that. I have issues with that. It just kind of bothers me. I just don't like the feeling. The reason why that happens is as you go down, you've got the entire mass of all the water sitting on you. So if you think about this, as you move down in here, you've got those masses of that water pushing down on you. So as you can see, this is, it's got different depths here, but the atmosphere increases quite drastically. So when you go about 100 feet down, you're 4 times the atmospheric pressure that you started with. So that's really significant. And if you look at volume of gases, the volume of a gas is highly influenced by the pressure around it. So here you've got, this is just a balloon. So if you have like a balloon, you've got a certain pressure, atmospheric pressure pushing around it, but you've got the air inside, so the particles of gas inside. As you move down here, the pressure is increasing. So what that means is you've got more forces, more pressure pushing against it. So it's pushing the gas particles closer together. So in that first balloon, you've got your gas particles, and by the end, it's very small because the gas particles are being forced together to be much closer to each other. So volume changes. So why don't you hold your breath when you rise to the surface? If you are down at the bottom here, I can't draw. I'm going to try to draw a lung. Okay, that's supposed to be a lung. Those are lungs. Clearly, those are lungs. If you inflate your lungs when you take a big breath of air from your gas tank at the bottom and you expand your lungs like this, as you rise to the surface, what's going to happen to your lungs? Yeah, that gas is going to expand. It's going to want out of there. And then what's going to happen? Goodbye, scuba diver. Scuba diver dies. And that's called the bends. And we actually will talk about that more in detail in one of our later lessons here. So that's it for today's lesson, a little shorter, which is good. I know yesterday's lesson or the other day's lesson was way too long. You are now assigned exercise 1 and 2. So hopefully you have the exercise package for this. I think it was on yellow paper. It is at the school in the Commons if you want. I will attach a file to it to the website, but if you want the hard copy of it, it is at the school and on the stage. Again, my name is located on the stage in the Commons. You can't go anywhere else in the school, but they are letting you just walk in to be able to pick up some supplies. Okay, that's it. We'll take a look at the answers to these later. Okay,